Alright everyone, welcome back to the day 21 of our daily leetcode challenge, and today we have got grid game. In this question they have provided us with a matrix of order 2 cross n, meaning it has got 2 rows and n columns, and we have two robots starting from this index 0 to 0 comma 0 and eventually going all the way to n minus 1 comma 0. So basically this one at the bottom, so they will be starting from this corner all the way from here. They have to go from 0 0 to 1 comma n minus 1. This corner they have to go, and robot A starts first and robot B will start after that, and both of the players are playing optimally. So what this means is robot A is trying to minimize the score that robot A is gonna have, and robot B is trying to maximize its score. So what I mean by that is whatever path robot A takes from in the case where he wants to travel from 0 to 0 to 1 comma n minus 1, it could take either this path right here, or this could be another path, or this could be a path. So if we see, no matter which path this robot 1 chooses to reach from 0 0 to 1 comma n minus 1, no matter what path it chooses, it will always split the entire grid in two regions. So let's say that the robot takes this path right here. If this path is taken, it means that all these values in this cell have now been completely taken and cannot be used any further by robot 2. So now robot 2 will basically will either choose values from this grid or this grid, because now since this is done, entire value has been taken. So when robot 2 starts moving, it will either have to go from all these values and go down, or go from all these values right here and go like this. So these are the only two paths valid, because all these values right here will be taken by the first robot. So the robot 1 is only having access to either all these grids and then come down here, because of whatever values are up till here, either it can choose these values or it can go directly down and take these values right here, in the first grid, in the bottom half. So it only has two options. Whatever is maximum at that point, it's gonna choose that. So let's say that robot A chose this path, it went from this side. In that case, these values will be completely taken up, which is these values right here. All these values are taken by robot 1 because it chose that path, it chose this path right here. Now since all these values are taken, robot B has no option but to take the remaining values, which is in the upper grid, and in the lower grid there's nothing much left. So it's 0 here and 9 here. So if the robot A takes this path, then in that case robot B will have to choose between this and this, the lower and upper, and it will be the maximum it will choose. So if the robot A chooses this path, robot B is gonna get 9, and if robot A chooses this path right here, that would mean that these values are colored or occupied. In that case, robot B can either choose this path, the lower grid or upper grid. Every time the path, no matter what path the robot A takes, the robot B is gonna be having to choose between the values in the upper grid or the lower grid, the sum of the values in the upper grid and the lower grid. In this case, it's only four upwards and 1 right here. So in this case, 4 it will choose. So if it would have been chosen, if the robot chose this path, we saw that it was 9, and if this path, and if it chooses this path, it's going to be 4, and so far, in the same manner, if the robot A chooses this path, then in that case these values are again covered, which are this. In that case, robot B is left with no option but to choose this one, 6 right here. So this is why in this case, that in this diagram that it shows here, once it travels like this, the robot A travels like this. In this case, robot B chose the upper path because 4 was the maximum, so it chose the upper grid. Or it could choose the come down here and then travel all the way straight. It cannot go back after that. Either go straight and come down at the last index, cannot come back in the middle, because it will be taken by the robot A. Same, let's take example of this case as well. In the second example, In the second example, if the robot A chooses this path, again there are three possible possibilities. This is path 1, this is path 2, this is path 3. Now let's analyze each path. If the robot A chooses this path, then that would mean these values have been completely used. So now in the upper grid, the values that the remaining values are 4, and in the lower grid it's 0. So if the robot A takes this path, then robot B is gonna get only 4. Then let's say that if robot A chooses this path, in that case these values are gonna get covered. And in the lower grid, you will see that robot B has either 8 to choose from or 1. So again, it will gonna choose 8. Maximum it will choose. So 8 you will get. The robot 8 chooses this path, so 8 he will get. In robot B will get 8. Then again, if robot A chooses this path right here, which is the third path, this path, all these values get covered. In this case, in the upper grid we're gonna have 0, lower grid we're gonna have 13. So again, robot B is gonna get 13 in this case if this path is chosen. So what we conclude is that if robot A chooses this path, then in that case robot B is gonna have left with 4. If it chooses this path, then it's gonna have left with 8 or 1, so which is 8. And if it chooses this path, then the sum of the values in the remaining 13 is what it's gonna have. So that is why, and since the robot A wants to minimize the score that robot A, it wants to choose a path such that the robot B gets the least amount of score. So in that case, it's gonna choose this path right here, robot A. This is how robot A is playing optimally to reduce the score that is that has been occupied by robot B. So in this case, this 3 plus 1 4 would be the minimum this robot B can get. So that's what we need to find, the minimum that can get. So it will be which path robot A chooses so that B's score is minimized, and in this case it's 4, and we saw why. If robot A chooses this path, we get 4. Now let us also see how we can quickly find, we what we are seeing here is, no matter what happens, no matter what path robot A chooses, this entire grid gets split in two, which is the upper grid and the lower grid, and in turn we are only returning the sum, or the sum of the remaining values. And whenever the sum of remaining values comes, or sum in ranges come, you should always think about prefix sums. So if you take an example of this path right here, we saw that 13 was the score because we summed all these values to quickly find the sum of the lower grid, which was 13. And in this case, in the upper grids, in the entire upper matrix, upper row was taken, so we had nothing left, so it was 0 in the upper grid. So for if you take it in the sense of robot B, what robot B is left with, it is left with something like this. All these are zeros, and 8 and 5 is what is left. So that is why the sum was 30. So what we can do is we can have another kind of an array which will be the prefix sum of all these values in this original array. So what I mean by that is 2 will come here, and then 2 plus 5 7 will come here, and then 7 plus 4 11 is going to come here. Same here, 1 plus 1 remains the same, 1 plus 5 6, and then again 6 plus 1 7. This is how we are storing the prefix sum, meaning the sum up till this value in both upper and lower grid is 2. Sum up till this value in both upper and lower grid is 7 and 6. Sum up till this value in the lower and upper grid will be 11 and 7, which is sum of all these values. So no matter what path is chosen, we can at any point quickly tell alright, this is what we're gonna have with by reducing this value and this value, which will be 4. So 4 in the above value and 1 in the remaining one. This is where the prefix sum is gonna help us to find what value is gonna be left in the upper grid and the upper row and the lower row. So this is how the prefix sum is gonna help us. If I code this up, you guys will understand better. So first is what I need is the length of the row, which is n, which is nothing but length of this grid. And once we have that, we need to find the prefix sums first. Prefix sum as in this value right here. So we can clearly do a copy. We can make a copy of the first row to find the prefix sum, and copy of the second row. Once we have that, we can modify this row 1 and in place to find the prefix sums. r minus 1. This is why we are starting with the first index, row 2r. Now we have row 1 and row 2, which are nothing but the prefix sums. Now if we try to iterate, now we know that it's gonna either with whatever path it chooses, it's gonna be splitting the grid in two parts. So it can either go down at this index, as we saw, either at index 0 or at index 1 it can go down, or on the last index it can go down, robot A. So if we try to redraw everything and start again using the prefix sums we have, so what is the first case that robot A can take? If it goes down right at index 0, if it goes down like this, then we have to take the entire sum that we have so far for finding what is at the upper grid, entire sum that we have so far in the upper grid, which is like 5 to 7 and 11 as of now here, minus this right here, because robot A chose this path, so minus 2. So 11 minus 2, which is 9 remaining in the upper grid if robot A chooses this index. And in this one, to find the remaining left, since this entire values are gone now and we are at this index, so we are at index 0 and we have to find the value which is left so far. Since no value is left, so whenever we have an index 0, a row 2, to find the prefix in this case at index 0, it's going to be the value just before this. So since this is 0, so we'll just kind of fix this to 0. So since there is no value behind it, now let's take the example of if robot A chooses to take a bottom entry at index 1, which is this path right here. So what are we left with? We are left with so far in the prefix sum of this on the upper array, we had 2, 7 and 9. So basically what we are doing is, in this entire sum that we have, we are removing this sum since this path is chosen, right? So what we are doing is, up till here we had the sum as 9 and here we had the sum as 7 plus 4, so this was 11, not 9, this would be 11. So since to find the remaining, what we can do is 11 minus this index right here, so this will turn out to be 4. So this is what is remaining. So in this case what is happening is the final value minus what index you are currently at. This is how we are getting the sum for the remaining part. What is the value at the last index, which is 11, and the value at the current index is 5 in the prefix, actually 11 minus 7, which is 4. This is how we are getting remaining. And for the bottom again, which is whatever index we are at, the value at just the previous one in the prefix one. So in the prefix we have 1 and then sum of this and 5 is 6 and 2, 5, 4, 6 and 1 becomes 7. So at this index right before it becomes 1, so the remaining value in this case will be 1, and it has to choose between 4 and 1, so it will choose the maximum always. So this is how we are going to iterate the prefix array now to find the sum. So at each index it can make a split, it can split the array. So we have to find the top score and the bottom score. The top score will always be the score at the last index minus the score at the current index right now. This is what the remaining score will be, top score, and bottom score will be always the value at the previous index, whatever r we are, the minus 1 of it, if r is greater than 0. Else we'll keep it as 0, because we saw in this case if it jumps right here, this is path it takes, then for the bottom score it's 0. Since we are at 0th index, it's 0, but at this index we're going to take the value at the last index, which is 11 minus 2, whatever sum is at that index so far, so 9. That is why we have 5 plus 4 as 9 as the remaining. This becomes 9. This is how we are subtracting the prefix sum. We are subtracting the prefix from sum at this index, which is the last index minus 1, and the index that we are currently taking a right at the bottom shift we are doing, which is at index 0. So 11, whatever prefix sum we had so far at index r, which is 0 right now, so 11 minus 2, 9. So this is how we are getting the top score and the bottom score. So and now again out of these two score, robot 2 is gonna take the maximum, right? So let us define a score here as min score, which will be the, or let's define a variable called score, which will be the robot's B score. It will be the max of top score and bottom score. The top score right here and the bottom score right here. This is the score that robot B will like to take. And since robot A wants to minimize this score, so it will always make sure that no matter what happens, this score is minimized for robot B. So robot A is gonna see what scores robot B can have if I choose this path, which is at moving down at index 0, moving down at index 1, and whatever score it gets, it will choose the minimum out of it, so that's what B is left with, since robot A is trying to play optimally and B is playing optimally by doing this. And now to minimize this, let us create one more variable here, min score, and set this to as infinity for now, and we will minimize this. So min score will again become the minimum between this value right here that we got score and the min score. So initially this is infinity and this is the value that we got. If there's any value which is further down the line, further down the iteration, if there's any value which is even lesser than that, it is going to update it to that one, and keep doing that, so that we are only left with the minimum score that robot B can have. This is the minimum score robot B can have. So this is the final solution. So this is how we are doing it using prefix sums. Every time a robot A splits, no matter which move it takes, it's going to split the grid in two parts, and that sum of values we can find quickly using prefix sums. And once we have that, we need to find the maximum of those two scores and assign that score to robot B, because that's the only possible way it's going to take that score. And eventually we'll finally minimize that score so that the minimum is identified. Now let's try to run these on the test cases that we have. Yeah, it's satisfying the test cases. Let's submit this. So as you can see, this is beating a 135 millisecond time, and this is going to be a linear one, because again we are only iterating the matrix, not iterating the entire matrix, we are just iterating the rows, and we created a copy of it. So this should probably be a linear solution. Yeah, so that was it for today. I'll see you guys tomorrow.